Alrighty, here we go. This is page, let's see, I think it's 99. Cool. So what I need you to do is get your textbook out. I assigned a few of these, and then we're going to work through a couple of the challenging ones. These are multi-step things, and you're practicing all of your operations with rational numbers. Oh, what's a rational number? Remember, that means any number that can be written as a fraction. And when you turn it into a decimal, it's a decimal that makes sense as far as how it behaves, meaning it either terminates, stops, or it repeats. So it's predictable. You know what's going to happen. So here was the thing about question number 4. Read through it first, because you start off with 3 rock climbers, and each person is carrying 7.8 kilograms of equipment. So off to the side, I'm thinking, all right, I've got 3 people. Each of them is carrying equipment. This 4th climber has no equipment. They're joining the group. So realizing that that's unfair, what they're going to do as you read through this, 1 decimal place, this is the total amount of weight I have right now distributed amongst 3 people. The group decided to divide the total weight equally among the 4 climbers. So now you have to take 23.4 kilograms divided by 4. I don't have to move any decimal places, so just proceed like you normally would. I need you to make sure you're showing work because I'm not allowing you to use a calculator yet. And you have to persist until the decimal either repeats or terminates. And in this case, it's 5.85 or 5 and 85 hundredths kilograms. So make sure you're showing me work. Look for where your work is that I can see it, and then have it labeled and your correct answer. Number 5, this one is similar to the problem we did in class, where we're trying to center this photo. You have 12 inches total, and how far from each side of the page should he put the picture? So if we think of it this way, you have 12 inches from here to here. This is your page. We're going to take this 3.5 inch chunk out of here because this is the picture, and we're trying to figure out what are those 2 pieces. Okay, so the first thing you need to do is subtract away the 3.5 from the 12. Now I see this happen a lot, and whether you use a decimal or a fraction, realize you're not going to get 9.5. You really, in theory, have to borrow here. Okay, you can do it in 2 chunks if that's easier. Take away 3 and take away another half, or go through the process of borrowing to realize that you have 8.5 inches left. Now, 8.5 inches are both of these together. So this x and this x, unknown values, is 8.5. So what you're going to have to do, that's really like 2 of those, you really have to take 8 and 5/10 or 8.5 and divide it by 2. Now, in this case, using decimals might be easier for you than using mixed numbers and fractions. I'm going to erase my stuff so that I have a little more room. But if you want to do it with decimals and say 8.5 divided by 2, go ahead. Okay, turn this into a mixed number, or one improper fraction from the mixed number. Remember that dividing means multiply by the reciprocal of 2, which is 1/2. Okay, you'll get 17/4, which is 4 1/4 inches. If you did it decimal way, you would have taken that 8 and 5/10 and divided it by 2. That gives us exactly 4 in front of the decimal. And now you have to persist. Oh, wait. Yeah. Don't bring down the 5 yet. That goes in there twice. I can't do math this morning. Can you tell I haven't had coffee? Oh, yeah. You'll get exactly 5, and we're done. Okay? So if you write it this way or this way, and again, make sure you show me some work. Number 6 on this one, Diane is serving breakfast to 2 groups of children. at daycare. And so the younger children don't get as much cereal as the older ones. So what we have to figure out here is that out of the 12 cups, she needs a third cup for each younger child, 3/4 cup for the older child or older children. We have 11 younger kids, so I'm going to have 1/3 cup times 11 because this is my younger children. And then I have 3/4 cup for the 10 older kids. These are the older ones. Together, we have to figure out the total and see. I want to kind of plan ahead. I don't want to promise that they're getting Fruity Pebbles or something, and then I don't have enough cereal. Then someone's going to get angry. So 11 times 1/3. Multiplying's great. I don't need a common denominator. Go straight across the numerators and denominators. Simplify if you can. Same thing here. Except over 1. Except instead of putting 30/4 for the older children, I'm going to simplify this one because there's a factor of 2 in both the 4 in the denominator and the 10 in the numerator. This is going to give me 15/2. Oh, hold your horses. Can't add fractions until you have a common denominator. It looks like with thirds and halves, I'm going to have to change everything into sixths and go to town here. So 11/3 becomes 22/6. This I'll have to multiply by 3/3. 45/6. That's hard to say. Gosh, so we get 67/6. Now, a lot of times in algebra, I say, go ahead and leave that or the improper fraction that way, but we really need a clue as to how much this really is. So turn 67/6 into a mixed number. So as you're thinking about how many times 6 can go in there, I know it can go in there 11 times. That'd give me 66, and I'd have 1 left over. Hey, that's the total cups of cereal I need. I have 12 in the box, so I'm just going to make it. I'll have a little bit left over. 11 1/6 cups needed. So will she have enough? Yes. There will be 5/6 cups left over. Now I know that's not the best sentence, but we're getting there. Okay. Let's go on and do a couple more of these. Number 7 talks about, here's a football field, and when they number this, here are your goal lines and the 50-yard line's in the middle, and they don't go from 0 to 100. 50 is in the middle, and then it kind of flip-flops back and forth depending on whose side of the 50 you're on. So it says the referee is standing somewhere. I don't know where, but when the quarter changed, they have to go to the same position on the other side of the field, wherever that may be. And it said that he walked 41 3/4 yards to a yard line with the same number on the other side, and he was exactly, the goal line is G, who's standing. He walked to a yard line with the same number, and he had just left. How far is he from the goal? Okay. Now, if you're not as familiar with football, this thing's going to be a little more confusing. So let me get some of this work out of my way. And let's talk about looking at the whole field. The whole field's 100 yards, okay? He walked 41 3/4. Now, it's up to you if you want to change this into decimals or leave it as a mixed number. I'm going to leave this as mixed number now, except that I don't have any fourths to subtract from. So I'm going to borrow 1 from the 100 and make this 99, and then I'll have 4/4 here. Then we can subtract, okay? That gives me 58 1/4. All right, so there's 58 1/4 yards left, okay, because this chunk from here to here is the 41 3/4. So somehow this chunk and this chunk have to total up to 58 1/4. We need to basically now divide this by 2. All right. So you decide if you want to take 58 and a fourth divided by 2 this way and go ahead and turn that into an improper fraction, which is 233 fourths times, because you change dividing to multiply, the reciprocal of 1/2, or of 2 is 1/2, and you get this, 233 over 8. Okay, or if you'd rather work with decimals, you could write 58.25 divided by 2 and do it this way. 2, well, I know it's 29 because 29 times this is 58. All right, bring down the 2, that goes in there once. I get a remainder of 0. I have to still continue on until I have either a repeating pattern or my decimal terminates, and I get a 5. You're either going to get 29.125 yards if you wrote it as a decimal. I want you to start getting familiar with the eighths as decimals. Okay, 29 and an eighth. If we had gone and simplified that improper fraction, we would have gotten 29 and an eighth as well. All right, last one. Okay, it's a 50 question test. Donovan got 39 out of 50. Okay, stop right there. So here's Donovan, 39 out of 50. Marcy's score was 10 percentage points higher than Donovan's. Okay, hold your horses. First, we'd better get Donovan's score into a percent, and a percent is how many out of 100. Now, this particular one, because it's 50, this should be pretty straightforward how to turn this into percent, because I can just multiply it by 2 and get 78 over 100. That's the equivalent fraction from Donovan's score. So Donovan scored 78%. Marcy's score was 10 percentage points more. So Marcy would have gotten 88%. And the reasoning is that 39/50ths is 78%. And there's my work to justify and show why that's true. Number 9 says, how many more questions did Marcy answer? Well, I don't know how many she answered just yet. Hold on. If Marcy, so show this work, Marcy got 88 out of 100 for the percentage. In simplest form, turn this into simplest form. Well, I shouldn't say simplest form. Let's just get it this far. Get it to a denominator of 50. And I'm doing that because the test had 50 questions. If I do this, Marcy got 44 out of 50 questions correct. It said there were 50 questions. Okay, so Marcy got 44 questions correct, and Donovan had 39 questions correct. So now if I subtract these two, Marcy got 5 more. Answered 5 more questions. Just have a seat. I'll be with you in a second. Answered 5 more questions. All right, last but not least, how can you check for reasonableness? Well, I would say just by looking at this part, 39 out of 50, okay, which is, it's exactly equal to 78%, okay? Marcy should be a little bit higher because she got more questions right. Should be a bit more at 88%, and it should be about the same relationship with the questions. Okay, I'll talk to you more personally about the more detail on that one. I wanted to make sure you at least got these ones. All right, it'll be time to move on to the next station soon. Just a minute.